Most people worry about the pH of their water without knowing what number actually matters. You've probably heard that higher pH water is better. Maybe you've seen bottles labeled 8, 9, or even higher, suggesting they're somehow healthier. But when you stop and ask a simple question, what pH should drinking water actually have, the answer isn't as extreme as it might seem. The confusion comes from mixing two different ideas: water quality and water chemistry. pH is a measure of how acidic or alkaline something is. It runs from 0 to 14, with 7 being neutral. Most natural drinking water falls somewhere between 6.5 and 8.5. This range is generally considered acceptable for drinking water systems, but here's the key issue. People often assume that pushing pH higher automatically improves water. That's not how it works. pH is just one characteristic. It tells you something about the balance of acidity, but it doesn't tell you whether the water is clean, safe, or free from contaminants. Water can have a good pH and still contain substances you wouldn't want to drink. This is where mistakes happen. Instead of focusing on what's actually in the water, many people focus on adjusting pH as if it's the main factor. They may invest in systems designed to increase alkalinity without first checking whether the water needs to be filtered. In practical terms, that means solving the wrong problem. Let's break this down more clearly. If water is too acidic, say, below 6.5, it can be slightly corrosive. Over time, that might affect pipes or fixtures. In some cases, it can also influence taste. If water is too alkaline, well above 8.5, it may start to taste flat or slightly bitter. It can also leave mineral deposits over time. So there is a reasonable range where water performs well, not too acidic, not too alkaline, but within that range, small differences usually don't have a major impact on health for most people. This leads to an important point: your body already regulates its internal pH very tightly. Drinking water that is slightly more alkaline or slightly more acidic does not significantly change your overall balance. Your system adjusts naturally. So chasing a specific number, like 9 or higher, is often unnecessary. What matters more is consistency and safety. Now let's talk about what pH does not tell you. It does not measure contaminants. It does not indicate whether there are heavy metals, chlorine, bacteria, or other unwanted elements in the water. A perfect pH reading does not guarantee clean water. This is why filtration is often more important than pH adjustment. Filtration addresses what's in the water. pH adjustment changes how the water behaves. These are not the same thing. If your water source has known issues such as sediment, chemicals, or aging pipes, those should be addressed first. Only after that does it make sense to consider fine-tuning characteristics like pH or mineral content. Another factor to consider is taste. Some people prefer water that is slightly alkaline because it feels smoother. Others prefer neutral water. Taste is subjective, and small changes in mineral content can influence how water feels when you drink it. But again, this is a preference, not a requirement. It's also worth mentioning cost. Systems designed to increase pH, such as alkaline water machines, can be expensive. If the primary goal is to improve water quality, there may be more direct and cost-effective solutions. So before focusing on pH, it helps to ask a simple question: what problem am I trying to solve? If the concern is safety, the answer is filtration and testing. If the concern is taste, small adjustments might help, but they don't need to be extreme. This brings us to the key insight: the right pH for drinking water is not about reaching the highest number. It's about staying within a stable, reasonable range while ensuring the water is clean and reliable. For most situations, water between 6.5 and 8.5 is perfectly acceptable. Within that range, other factors matter more. When people shift their focus from chasing numbers to understanding their water source, their decisions become simpler and more effective. Instead of asking, "How can I increase pH?" they start asking, "Is my water actually clean?" That question leads to better outcomes, because once the basics are covered: safe source, proper filtration, consistent quality, everything else becomes optional. In the end, pH is just one piece of a larger picture. It can influence taste and behavior, but it doesn't define whether water is good or bad on its own. Understanding that helps you avoid unnecessary complexity. It also helps you focus on what actually improves your daily water. If you found this explanation useful, consider subscribing for more clear and practical breakdowns like this. In the description, you'll find a simple resource that helps you evaluate your water setup step by step, so you can make decisions based on real conditions instead of assumptions.